a nerd of the 1940s. I liked making things, building radios, aeroplanes. And going on to university, we did the graduate research just at the beginning of the International Geophysical Year, which was a big jamboree of science before the space age. And for that, I established an observatory in Lae, New Guinea, in the days when there were still cannibals up there. A very interesting time. And that led to me getting an offer from the Massachusetts Institute of Technology. And I've made a great discovery there. There was this huge computer for that time, down in the basement, the whole basement. And I used that to very great effect to find out what the magnetic field of the sun was. And from that, I very quickly moved into the space research. Well, my first highlight was when we had my instrument on 6 different satellites spread all around the solar system. And we were getting back information on the effect of solar flares and the cosmic radiation that was accelerated in them, not only here at Earth, but as it was propagating throughout the whole solar system. And of course, at the time, it was a very important part of the preparation for the astronauts to go to the moon. So that investigation really was technically and scientifically a huge highlight. My second highlight was when I was able to apply our space technology in the practical application of minerals exploration. We had learned technology in the spacing era that allowed us to look through the very thick overburden, as it's called, the soil on top of the Australian continent, and see the minerals underneath. And even more importantly, we could use the first of the remote sensing satellites used for civilian purposes, Landsat, and revolutionise, in fact, the manner in which geologists began exploration. It is true that they initially called it remote non-sensing, but once we got some very good imagery of some spectacular country in Australia, they changed their mind very quickly, and remote sensing and now is a key part of exploration. And my third highlight has been being able to use ice cores from the Antarctic and the Arctic to see what the sun was doing thousands and hundreds of thousands years ago. And with that, we have found that the sun has waxed and waned enormously in its activity, and it allows us to predict the space weather in the future. Those 3 very different highlights have really been a very important part of my career. Yes, advice to my younger self. Well, when I think back, I was very fortunate that many good things happened to me for several reasons. One was that I learnt to manage risk. I had been an avid mountain climber in the very rough parts of Tasmania where you did not have much help or hope of rescue. I learnt to manage risk there, and that carried over into my space research. As a scientist, I both was an experimenter and competent in theory, a very important combination which has led to a great deal of success on my part. And thirdly, I have found the value of changing from one field to another. Changing from building satellites to go around the sun, to instruments that would go in rockets launched from Woomera, learning then that technology and knowledge would allow me to explore for minerals in Australia, and then interpret the results from ice cores which had been laid down in the ice hundreds of thousands of years ago. The ability to move from one field to another was a very important thing which was crucial in some of my development. These three pieces of advice I would say to my younger self: do it like that again. I attended my first COSPAR meeting in Florence in 1961, and that introduced me to the world of science in a way which was quite crucial for my development. I learnt that scientists are uncertain. I learned that in space we knew very little, and I learnt that some of my ideas were not quite as stupid as when I was young in Tasmania I thought they might be. Then throughout my career, COSPAR has allowed me to interact with people from many countries. I have developed many great colleagues through that interaction and gained many interesting insights during meetings, which have then developed into substantial research. And of course, COSPAR, through its publications, has provided another avenue for me to be able to explore the world and communicate with the world. All in all, through its international reach, COSPAR has been an extremely important part of my career, and I thank them. Well, I think it's very much a continuation of my Bronze Age space science. I have been particularly interested in what's called the Hallstatt periodicity, where the sun varies with a periodicity of 2,300 years. And the physics of that and the implications for life on Earth in the past, because it has probably resulted in extinctions of certain species. More of that research, understanding the effect of that changing sun, what it will do for space research in the future, and learning more about the past is where I think I will be spending my scientific activities in the future.